and we'll start with individual demand. Now we know from our previous discussions of supply and demand that when price changes, quantity demand will change. And the reason we showed that demand relationship is with a graph with price on the vertical axis and quantity demanded on the horizontal axis. And usually that relationship, that demand relationship, was downward sloping, demand to the land. What we saw in the last chapter, however, is that people tend to make choices between two goods. In this case, food and clothing, and they make those choices over a fixed budget set, and they make them in a way to maximize their utility. From these two concepts, the preference concept and the demand concept, we're now going to explore something new. We're going to explore the ways in which consumption of food and clothing change when the price of food changes. So what we've graphed out in this figure over here is a price consumption curve. And what it shows is the consumption choices that a person will make when allocating their fixed budget, their fixed income, between two goods, in this case, food and clothing. We note from our demand curve that as food gets cheaper, people tend to demand more food. A reduction in the price of food, with income and the price of clothing fixed, causes the consumer to consume more food, putting them in both a different market basket and a higher utility curve. In this first panel, these blue lines trace out our consumer's budget. And we see that as food gets cheaper and cheaper, a consumer has different utility maximizing bundles. Those bundles trace out their price consumption curve. From these utility maximizing bundles, A, B, and D, we can then graph their individual demand curve. Note, it's downward sloping, demand to the land, with price on the vertical axis and quantity demanded on the horizontal axis. To put a finer point on that definition, the price consumption curve traces out the utility maximizing combination of two goods as the price of one changes, and from here we can derive an individual demand curve. Remember that demand is just a relationship. Forgive my bad handwriting. But that says relationship, and what it's relating is the quantity of good demanded to that good's price. So now that we've derived a demand curve, we can identify two important properties of demand, and in particular of individual demand. One is individual utility changes as we move along the curve. Note how this comes from our well-behaved preference properties that we talked about. More is better than less, and people tend to not be satisfied. So as the price of food drops, we can consume more food, and that greater and greater consumption makes us more and more satisfied. In other words, it puts us on a higher utility curve. Also note here that there's nothing about this relationship, this level of utility that we're talking about, that needs to have a number associated with it. In other words, we can really stick to that set theory, that ordinal level of utility, where all that matters is its relative position to other market baskets. The other interesting property of this individual demand curve is that at every point, we're assuming that our consumer is maximizing utility. And they maximize utility the way we learned in that last chapter, where the marginal rate of substitution is equal to the price ratio. This property right here is what that paper we read, that Becker and Stigler paper, BNS 79, is telling us. That all there is utility maximization. And certainly there are rational critiques and relevant critiques to that paper. But what we're saying from this demand curve is that at every point, the consumer is maximizing utility. And the fact that marginal rate of substitution varies along the demand curve tells us something about how individual consumers value consumption of any particular good or service. So we derived that demand curve using that thought experiment we like so much in econ. Ceteris paribus, all else equal. We held the price of clothing, the other good, fixed. We held our income fixed. But of course, the economy is dynamic, things are always changing. All else is not always equal. And in particular, we're concerned with how demand changes when other things change. Let's start by looking at income changes. And just like we saw a few slides ago with price changes, when income changes, our utility maximizing bundle will also change. So previously, we were looking at the impact of price changes, and we looked at how that influenced our budget set. Those are these straight blue lines right here. So when a price changes, the budget set will rotate outward. But now, because income is changing, what we're seeing is not a rotation, but a shift, a parallel shift out of the budget line, placing us at higher utility curves. As our income increases, with the price of all our goods fixed, consumers now re-optimize and change their choice of market basket. And we see from here, we can then trace out what's known as an income consumption curve. The fact that this particular income consumption curve, the one between food and clothing, is upward sloping, implies that food is a normal good. In other words, an increase in income causes a rightward shift of our food demand curve. We see this in this second panel down here, where the rightward shift of our demand curve in response to this increase in income corresponds to new optimal market baskets. To put a fine point on it, what the income consumption curve does is trace out the utility maximizing combinations of two goods as our income changes. We'll note, however, that this rightward demand shift isn't true for all goods, and it's not true across all income increases for all goods. You might remember a term of art from earlier in econ, inferior goods, which is a good for which your consumption decreases as your income increases. An inferior good is one where an increase in that person's income can lead to less consumption of one of the two goods in your budget set. Remember, we like to think of ramen noodles relative to other meals, or crack rocks relative to powdered cocaine. However, inferior goods are actually more nuanced than that, because you can see goods that start out as normal, where small increases in your income, or increases in your income when you don't have that much money, cause for an increase in the quantity demanded of that good, but become inferior once that income consumption curve bends backward. We see that in this graph, where hamburger starts out as a normal good, an increase in our income from here to here leads us to consume more hamburger. But eventually, as we get wealthier and wealthier, more and more income, our income consumption curve bends back as we shift our consumption from hamburger to steak. We can see this more clearly with a construct known as the Engel curve. Engel was a 19th century statistician in Germany, and he wanted to study family budgets to learn more about their consumption and expenditure patterns. You might note that this sounds a lot like the income consumption curves we talked about on the last slide. Where we might start with a normal looking good and see that income consumption curve bend backwards. An Engel curve translates that income consumption curve to relate the quantity of a good consumed to its income, but rather than the amount consumed of the second good on the vertical axis, we have income on the vertical axis. And for a normal good, an Engel curve is just upward sloping. As income goes up, quantity demanded of that good goes up. We might see, however, for inferior goods, an Engel curve bending backwards, whereas income goes up and income is on that vertical axis, quantity demanded of that good will go down. That's an arrow. Ignore my bad handwriting. Remember, however, that econ is not the only thing that might shift a demand curve. We're also concerned with the price of related goods. So far this lecture, we've been comparing consumption of food with clothing. We can now consider how our consumption of food changes when the price of clothing changes. Just to refresh everyone's memory, two goods are substitutes if an increase in the price of one good leads to an increase in the quantity demanded of the other. So let's talk about coffee and tea. If the price of coffee goes up and we demand more tea, quantity demanded of tea goes up as a result, coffee and tea might be substitutes. Two goods are complements if an increase in the price of one good leads to a decrease in the quantity demanded of other. So now, rather than coffee and tea, let's talk about coffee and milk. Now suppose that the price of coffee goes up. If as a result you demand less milk, then coffee and milk are complements. Not all goods have to be one or the other. Goods can be independent if a change in the price of one has no effect on the quantity demanded of the other. One interesting way to check whether goods are substitutes, complementary, or independent is to look at that price consumption curve that we talked about earlier in this lecture. The fact that these relationships exist, substitutes and complements, suggests that when studying one market, it might be interesting and important and relevant to look at related markets as well. And as you continue on as your career as economist, you'll start to see this when we shift from a partial equilibrium setting, like we're in now, to a general equilibrium setting. Now that we understand this demand derivation and some of its dynamic aspects, we can break it down a little further. In particular, we know demand to the land. Demand is generally downward sloping. So as price goes down, quantity demanded goes up. We can explore that further because a fall in the price of a good generally has two effects, causing quantity demanded to go up. The first one is the substitution effect. as a good gets cheaper, other goods are now relatively more expensive. So we're going to shift our consumption to that cheaper good. Keeping with the food and clothing example we were talking about earlier. And I'll graph out a little mock of our price consumption curve. As clothing got cheaper, we bought more and more clothing relative to food. But something else happened. This is the income effect. Because clothing got cheaper in this price consumption curve, we as consumers were effectively wealthier. The reduction in the price of clothing made it so we had more income. And as a result, we could sort of purchase more of everything. And this is where you see the income consumption curve start to slope up. This is the income effect. Now in practice, when you're at the store, for instance, these effects occur simultaneously and unconsciously. But for our analytical purposes, it might be useful to disentangle them and compare them to the total effect of a price change, which again is the substitution effect plus the income effect. So just to put a fine point on it, the substitution effect is the change in consumption of a good associated with a change in its price with the level of utility held constant. The income effect is the change in consumption of a good resulting from a relative increase in purchasing power with prices held constant. Keeping in mind that when a good is cheaper, it is both relatively cheaper and we are relatively wealthier. Let's start to decompose these effects if we have a normal good. And remember, a normal good is one that as income goes up, consumption goes up as well. So given that this is a normal good, we should expect to see a positive income effect. So we know that a change in the price of a good has both an income and a substitution effect. And in this case, we're examining a decrease in the price of food. So here we have a budget line and a utility maximizing consumer. This consumer is originally at point A on the budget line. When the price of food falls, we're going to be on a new budget line, this dashed budget line, and the consumer is going to pick a new utility maximizing bundle, this unit B. But it's important to understand how they get from A to B. First, we'll explore the substitution effect, which is the shift in consumption because food is relatively cheaper. For this substitution effect, we see that they'll move from A to this market bundle D. And the reason we know that they arrive at D is because we're holding their level of utility constant. A and D are on the same indifference curve. But because food is cheaper, we have a new price ratio. So to find the substitution effect, we're basically asking, what is the marginal rate of substitution conditional on being at this utility level, U1, with this new price ratio? And I'm just writing PR new. We'll explore the math in greater detail soon. Here, I just want you to think about it conceptually. Once we have this substitution effect, this move from A to D, and we see it down here. Once we have this substitution effect, the income effect is relatively straightforward because we just push them out to a higher indifference curve. And because we already have the new price ratio, the income shift is straightforward. So you'll see that this dashed budget line, and I'm going to clean up the slide real quick, that this dashed budget line is parallel to this hypothetical budget line that market basket D is tangent to. So the income effect is this additional consumption in food from market basket D to market basket B. And if we start on our original budget line, this line going from R to S, this budget line here, you'll see the new budget line, the line going from R to T, this dashed budget line, looks like what we think a drop in the price of food looks like, this rotation out of our budget line. But really what we've done is decompose it from the rotation and also the shift. It's fine if it's not super clear right now. We'll do more examples later to help you get the hang of it. What if the good is inferior? Well, remember, an inferior good is one where as your income goes up, quantity demanded goes down. So as we decompose the effect of a price change, we would expect the income effect of that price change to be negative because this is an inferior good. And here we see that right there. So let's explore and let's decompose the impact of a price change for a negative good. Same setup as before. The consumer is on this initial budget line going from point R to point S, this dark blue budget line, and they're initially consuming market basket A. As food gets cheaper, it's as if they're on a new budget line with the same indifference curve. This indifference curve, U1, but this new budget line, this light blue one, and they start consuming market basket D. That's our substitution effect. But there's another impact of this price change, where not only has food become relatively cheaper, but as a consumer, we are relatively wealthier. And that's that parallel shift from this light blue budget line to this dashed budget line, going from point R to point T. And what's happened when food's gotten cheaper, in the case of food being an inferior good, is the budget line has rotated out, looking like a move from this dark blue line to this dashed line. I'm going to clean up the board real quick. So we've already decomposed the substitution effect, moving from point A to point D. Now, since they're also relatively wealthier as a consumer, we see that they've moved from the income effect from market basket D to market basket B. And because they're now consuming less food, we can conclude a negative income effect and that food is an inferior good. It's important to note here that demand is still downward sloping. If we were to graph out price and quantity demanded of food, we would still see a downward slope, and the reason why is the substitution effect here is greater than the income effect. So though a pure income effect would cause them to consume less food, even when food is cheaper, this shift from market basket A to market basket B means they're consuming more food. What would it look like if that weren't the case? If the income effect were greater than the substitution effect? In other words, if we had an upward sloping demand curve, where a decrease in the price of a good led to a greater quantity demanded, that's a special type of good known as a Giffen good. In our readings, we're going to see if perhaps one exists, although typically Though some have been alleged to be documented, whether it's rice in China or gruel during the Irish famine, people tend to be skeptical of them. But we'll see from decomposing the substitution effect from the income effect that what you need to be a Giffen good is, one, a very inferior good, and also a very large share of your income. So much so that the income effect outweighs the substitution effect. What that would look like in practice is a consumer initially at this point A consuming less of the good even though the good is cheaper, even as they shift to that dashed budget line. That's all we have for individual demand. But remember, in econ, we're concerned with markets and marketplaces, and as a result, we want to know how we get from individual to market demand. And the way we do so, now that we've derived this individual demand curve, is the same way we did in Econ 101, where we just take the horizontal sum of the individual demand schedules. So in this case, where we have at a price of 1, individual A demanding 6 units, individual B demanding 10 units, and individual C demanding 16 units, the market demanding 32 units. Taking it back to individual demand for a second, remember what Becker and Stigler taught us, that all there is utility maximization. And at this price, at each of these prices, each of these individuals is maximizing their individual utility. And from there, we can derive a market demand curve. We can illustrate this with a table, or we can illustrate it graphically, where the market demand curve is that horizontal sum. For instance, here, at a price of $4, individual A isn't in the marketplace. That's too expensive for them. Individual B is demanding 4 units. So 0 units, 4 units. And individual C is demanding 7 units, bringing our market demand to 11 units. 4 plus 7 plus 0 equals 11. Just like we were concerned with what shifts an individual demand curve, we're also concerned with what would shift a market demand curve. We're concerned with market dynamics. And 2 points in particular stand out. One is the market is influenced by the number of consumers in that market. So as more and more consumers enter a market, the market demand curve will shift to the right, just by the mechanics of that horizontal sum. The other thing to note is the factors that influence an individual's demand curve will in turn influence the market demand curve as we aggregate up. It's important to always note that market demand curves are built out of the sum of individual demand curves. We'll go over elasticity pretty quickly because we already did it in Chapter 2. But the price elasticity of demand is the percent change in quantity demanded in response to a percent change in price. And remember, elasticity is a stupid word, but all it means is sensitivity. So when demand is inelastic, we are relatively unresponsive, insensitive to price changes. And when demand is elastic, we are relatively responsive, we are relatively sensitive to price changes. Because demand tends to be downward sloping, as price goes up, for elastic demand, we're going to demand a great deal less. Our quantity demanded is going to drop considerably as price goes up. Finally, we'll do a short review of consumer surplus. Remember that consumers benefit from participating in the market. There are gains from trade. And in practice, this is because what a demand curve is your marginal willingness to pay, and typically we are paying a market price below that. So mathematically, consumer surplus is the total benefit from the consumption of a product. It's the difference between that demand curve and the market price. It's shown in this figure here as the yellow shaded area. And we get it by, in this case, summing up these vertical rectangles. Where at a market price of $14, a person who is willing to pay $20, and I'm going to clean up the slide a little bit, but at a market price of $14, a person who is willing to pay $20 for a ticket gets 6 units of surplus, 20, 14. Person who is willing to pay 19 gets 5, and so on and so forth. Leading to $21 of total surplus. Since consumer surplus is the area between the demand curve and the market price, here again $14, we can just either take the integral or in this case do some basic geometry and calculate the area of that yellow triangle, 1/2 base times height. So here the height of this triangle is 6, $20 minus $14. The base of this triangle is 6,500. Note that its tickets are listed in thousands. So we get 1/2 6, that's 3 times 6,500 for a total consumer surplus of $19,500. That's it for this time. We went through this chapter fairly quickly because it's mostly review and derivation, but I'm really looking forward to seeing what you guys come up with for your paper discussions on Wednesday.